Okay, and then I'm gonna label a few things here so that we know how to name a circle. So we're gonna talk about circumference and circumference and area, which should be review for many of you guys. So when we name a circle, we're gonna put a little circle with a dot in it, the center. And then if there's a dot in the middle of the circle, like there is for the one I just drew, and that's C, then I would call this circle C. So you would see the little circle symbol with the dot in it, and then you would see C to the side of that. Let me move this here. Okay, then other things that are going to be new to you guys in terms of the explanation for it or the vocab for it. One thing that should be reviewed is what a radius is. So if I had a dot on the circle, on the edge of the circle called A, and this one's called B, then the radius is described as the length of a segment that extends from the center to one of the edges of this circle, or to an edge of the circle, a point on the edge of the circle. So when we're finding the circumference, we're finding the length. If we picture a rope going around the circle, if we unwrap that rope, the measurement of that rope is the circumference, and that's described by two formulas. 2 pi r is probably the one you guys are familiar with, but because multiplication is commutative, we can move the 2 and the r around. So this is equivalent to 2 times r times pi. And if we know that the diameter is twice the length of the radius, and we replace the 2r by d for the diameter, then these two formulas are the formulas that you will see in advanced level maths to represent the circumference of a circle, either d times pi, the diameter times pi, or 2 pi r. The area of a circle, I think all of you guys know, is pi r squared. From here, I'm going to describe a few things, one of which is to name a piece of the circumference. So this is called what we call an arc. Specifically speaking, there's two types of arcs. This arc that I'm tracing out is called the minor arc. It's the smaller arc. So underneath there, can you guys go ahead and write minor arc? And in this picture, the minor arc we would label AB, and we would put a little arc symbol above that. Okay, so again, the minor arc, maybe I'll highlight it for you guys here. The minor arc would be in yellow. Okay, and the definition of a minor arc, it's an arc with the measure, oops, it's supposed to be a parentheses. Measure of this arc is less than 180 degrees. Okay, so measure of that arc is less than 180 degrees. So if this the arc is less than a semicircle, we would consider it a minor arc. So think baseball, you guys. What's the opposite of minor in baseball? Think major, okay, like major leagues. So in this case, the arc is going to be the longer arc or the bigger arc. So by bigger arc, then let's highlight this here. Let's say that the major arc is in green here. The major arc, if the minor arc is less than 180, the major arc is defined as an arc greater than 180 degrees. So for the major arc, we can't say arc AB. So when we say arc AB, we're referring to the minor arc. So if we want to describe the major arc, which is bigger, we would need 3 points. So A and B, and then a point somewhere in between A and B. So let's go ahead and give this an extra point here. Let's call this point, I'm going to change the color here. Let's call this point here D. Okay, any point between A and B along the major arc would be needed to describe the major arc in the name of it. So we would say either BDA or ADB, where D is in the middle. And then you would have the symbol above ADB. Okay, and the measure of a major arc is greater than 100 degrees. Okay, and the last thing I'll mention with this is that when you're trying to find the measure of an arc, we would define the measure of an arc being equal to what is called the central angle. Okay, so let's say x degrees was the central angle. Okay, so another way they're gonna oscillate or switch back between giving you guys the measure of the arc or the measure of the central angle. You would say both are equivalent. So in this case, like the measure of arc AB is also x degrees. So whatever the central angle is going to be equal to the measure of the arc. So the full circumference is 360 degrees. We're gonna move on to the next page. I'll give you guys a few more seconds just to copy down what I have. We're not gonna do the entire next page. This page, we're just gonna do a few review questions, and then we're gonna move on to something called sectors and arc length. Oh, that's a good question. So if the arc is equal to 180 degrees, there's a special name for it. What do you guys call something that is half a circle? Yeah, it's either some people say semicircle or semicircle. Either one is fine, but it's a semicircle. It's not considered major or minor. It's like it's a special case. Okay, on the next page, the first question, really straightforward. You're given the diameter is 10. Figure out what the radius is, the circumference, and the area. So we're going to go backwards and figure out what the radius is first. So we're going to take half, get 5. And then we'll move through this one fairly quickly. Let me know if you guys have any questions. One big thing about this section that I'm going to mention for your quiz is that many of the directions will say, leave your answers in terms of pi. This is what we consider calculator ready form, meaning that we're not going to plug 3.14 in and come up with an estimate for it. The same for when we were leaving things in simplified radical form. And the justification for that is that this is an exact answer, as opposed to you enter in a decimal value, you get an approximation, and then it kind of makes the answer a little bit less accurate. The exception would be if the problem says round to the nearest 10th, round to the nearest 100th. If it's asking for rounding, then you're using pi in your calculator, coming up with an estimation. But most of the times, and I would say this is true for your quiz, it's going to say leave in calculator ready form, which means leave your answers in terms of pi. So for this one, it should make your calculation a little bit easier because you're just doing 2 pi r, which is 2 pi times 5. I would write the number that you guys get for multiplying 2 and 5 to be 10. So 10 pi is your answer. Okay, go ahead and calculate the area and then type in your answer into the chat. And if you guys can write pi as pi, on Desmos, if you guys type in pi, I think the symbol, I'll double check right now actually. I think the symbol pops up. Yeah, just so you guys know, in Desmos, if you ever need the exact pi value, you can just type in 25 and then pi, or you can use the pi button. So whichever is faster for you. But I always kind of like knowing those shortcuts because it does make it a little bit faster. So pi r squared. Once again, don't bother with the calculator for simplifying this when you guys are given the option to leave it in calculator ready form. Okay guys, so in the chat, if your radius was 3 rad 5, what would you guys say the diameter is? And I'm just double checking to make sure you guys know how to multiply that by 2. Okay, there was a couple people, no, one person. Okay, it was only one person that said 30 in the last class. So we want to make sure that the numbers that are outside the radicals are the only ones that we're multiplying together. So 6 rad 5 is the correct answer. Since this is asking for just the diameter, I'm going to leave that. I think Mia answered the question for circumference. If the circumference is described as d times pi, you guys can just attach a pi at the end of this to say 6 rad 5 times pi. Sometimes you'll see people move the pi, especially if there's a radical, because then the reader might be confused and think, okay, is the pi supposed to be inside the radical or outside the radical? And if you don't want that confusion to happen, another way of writing it is 6 pi radical 5. So typically the radical in an expression is at the end just to avoid the confusion. It's not incorrect to write it either way since it's commutative. But if you want to avoid the confusion, move the pi closer to the front. Can you guys go ahead and start to write out the area? Okay, I want to make a point of this. I feel like some of you guys know this, some of you might not know this. When you're squaring an expression like this, which is 6 radical 5 squared, please keep in mind that you guys can square, you can either expand it out and write 6 rad 5 times 6 rad 5, or you can distribute the radical or the square to the number on the outside, 6, and to the radical 5. So we have pi, and then 6 squared is, oh my goodness, do you guys notice I made a mistake? What's my mistake?
You put the diameter instead of radius.
Yeah, I put the diameter instead of the radius. Thank you. So 3 radical 5 is supposed to go in there, not 6 rad 5. 6 rad 5 is the diameter. So squaring, when we square, we want to square the 3, which is 9. The kids in the class, can you guys verify? Do you guys know how to do rad 5 times rad 5 fairly quickly now? What is rad 5 times rad 5? Just 5. Okay, so good. You guys, when you square something that has a square root, the square root will be undone. So you're just left with the number on the inside. Or you can, again, you can think of it as rad 5 times rad 5 is square root of 25. It's just 5. Or you have 2 5s in it, cross one, circle one of the 5s goes outside. But just either way, when you square the radical 5, it's not radical 5. That's probably one of the bigger mistakes I see. So it is just plain 5, no radicals left over. And so our final answer, move the pi to the end, 45 pi. Okay, sometimes we're given things and work backwards. We are expected to work backwards from there. So if I have the circumference, I'm going to have to get back to the radius for me to then determine diameter and area. So what I'll do is I'll set 36 pi equal to the formula for circumference, which is 2 pi r. Okay, so then if you guys divide things out and isolate r, which is what we're trying to solve for, we're going to divide 2 pi to both sides. When we do that, a pi divided by a pi is the same as like an x divided by an x. Those cancel out. 36 divided by 2 is then 18. All of that was to isolate r, which is now 18. Go ahead and finish off the problem and then type into the chat what you think the area is equal to. And you may use a calculator to simplify that as well. Okay, it looks like we have 324 pi. That is the correct answer. You squared the 18, 324 pi. And we do, sorry, I had to squeeze the pi in at the bottom. We do the same thing or something similar with area, except for the area formula has an r squared. So when we're trying to isolate r in this case, we can divide both sides by pi. But to undo the squaring, you guys are going to have to apply a square root or take the square root of both sides. In the chat, when you simplify square root of 75, because you always leave it in simplified radical form, can you guys tell me what the radius is equal to? Okay, 75 is 5, 5, and 3. hopefully you guys are noticing that simplifying radicals is now like as easy for you guys as simplifying fractions. Maybe not as quite as easy because you've been doing fractions for longer, but it should be to the point where you're just like 5, 5, 3. You can take a 5 out, 5 radical 3. And that comfort is going to be crucial for algebra 2 trig. When you guys are doing the trig part of it, it's going to be a step that you want to make sure you're comfortable doing. So 5 radical 3 is your radius, then the diameter we would conclude is 10 rad 3. Very good. And then go ahead and figure out the circumference. So if we interpret it just as the diameter times pi, you can write it as very good 10 pi radical 3 or 10 rad 3 with the pi at the end of it. So either one works. Sorry, let me get rid of this decimals. So far, I think most of this is review. I'm going to skip over some of the questions that we're going to cover on Monday. And then also we're not going to do 5 because 5 I feel like was like in the old days when we didn't really, we weren't asking kids to use the calculator so often. We would come up with 22/7 gives a really good approximation of pi. So it was a way to ask students to come up with a value for the area without, or circumference without having the pi in the answer, but we're not going to worry about that. So if you guys can scroll down to number 8, you're going to have a couple questions on the quiz similar to 8, not necessarily always this particular figure, but something with the same concept. If I asked you guys to find the area of that shaded region, can you guys just type out broadly, what would you guys do? In general, what do you do to attack a problem like this? You want the area of the shaded region. You don't have to actually use any math, just describe it in words. What would you guys do for this? Okay, very good. So find the area of the 2 separate shapes. You're going to have a couple of these where it might be a parallelogram inside something. It might be a rhombus. It might be a square. It might be a circle. So just be aware of that. Whichever is bigger is going to come first. So very good. So many of you guys said find the area of the circle and then subtract out the area of the square. So kind of have that as a strategy in mind for anytime you guys want the shaded region, the area of the bigger shape minus the area of the smaller shape. Okay, the area of the circle is going to be pi r squared. So we're going to go back to our picture. And they did tell me what the radius was. I can draw the radius anywhere I'd like, but I'm going to purposefully draw it so that it's also the radius of a square. So when we were talking about area of polygons, remember all polygons have a radius as well. So here's my radius. And then what I'm going to do is label that 2. Okay, so here is where I'd like to take a moment and have you guys think about the problems that you're doing. Okay, so when you guys had the square problem in your classwork, I think all the problems asked you guys to find the area of the polygon. But some of the questions that you guys might get on your quiz might give you the apothem of a square. So even though you don't necessarily need to do the area that way, I just want you guys to feel comfortable whenever you're given a square or an equilateral triangle that you can also do it the polygon way as well, which requires an apothem, which requires the perimeter. But if you're just faced with a question like this and you're just asked to find the area of the square and nowhere in the problem do they discuss apothem, then I think the easier way to attack the problem, which I think someone in another period is like, Mrs. Kim, why are you doing all of that work with the apothem? And because I want you guys to see that a square and an equilateral triangle are also regular polygons. So if a problem only gave you the apothem, that you could go from the apothem of a square to the area. So in this case, there's no discussion of an apothem. So I'm just going to attack this the easiest way possible, which is that if I have diagonals going through a square, it's going to create right angles inside because diagonals are perpendicular, diagonals bisect each other. So if that's the case, then you guys have a larger 45, 45, 90 triangle without having to drop the apothem. You guys have that these two sides are 2. Can you guys type into the chat if that's the case and you have this is 45 and this is 45, what's the side length of the square? Okay, and again, this is how one student approached the question of the classwork. And he was like, do we need to find the apothem? And once again, my answer to that is just, what if you were given the apothem? Could you find the side length? So I wanted you guys to attack the problem that way for that reason. So in this case, we don't need the apothem. We can determine that the side length is 2 rad 2 times it by radical 2 times the leg by radical 2 to get to the hypotenuse. So we have everything we need to answer this question. We'll start with the area of the circle first. Pi r squared, r is 2. We're going to leave our answers in pi form or with pi in the answer. And then the area of the square is side squared, so 2 rad 2 squared. Can you guys type into the chat, what's your final answer for this? Okay, so the area of the square, you're going to square the 2, square the radical 2, so 4 times 2, which is 8. So my answer to the whole problem would be 4 pi minus 8. We would leave our answers in terms of pi, calculator ready form. We don't have to enter in a decimal and move on. And then that's going to be your answer. So the next page, go ahead and go to the next page or find page 10 for me. Okay, page 10 should be like the new part of it. It's really quite simple from the perspective of proportion. So what we've discussed so far, if I describe a circle to you guys in terms of pizzas, we've described the area of the full pizza, and then we've described the perimeter or circumference of the whole pizza. But now what we're going to do is cut slices out. Okay, and so within a slice, we're going to talk about arc length. An arc length is basically a piece of the circumference. So what I'm going to do is draw out a slice of pizza. It doesn't matter how you guys draw this one. Go ahead and draw a slice of the pizza coming from the center. And then what I'd like you guys to do is with the highlighter, go ahead and highlight the word arc length. That symbol, by the way, is it's typically like a cursive L. That represents arc length. And I'd like you guys to highlight the arc length, which is basically what I'm going to call the pizza crust. So if you had a slice of pizza and I said, can you tell me how long that pizza crust is? You're going to imagine that you're going to straighten out the arc and then just measure that piece. Well, if you notice, this arc length is just a piece of the entire circumference. So if we knew what the entire circumference was, and we just took a proportion of that circumference, and you can see the word portion, proportional, the proportion or the ratio that you guys are setting up is whatever the measure of the arc is over 360, which is the whole thing, is going to be the ratio. So for example, if you guys were measuring a semicircle, it's 180 degrees. That's half the pizza slice. If you put 180 over 360, that's 1/2. That's going to get you half of the circumference. So here on the formula that you guys have below, it's whatever the ratio is, and M represents the measure of your arc. So M is measure of arc or central angle. Okay, and what they did between formula on the left and the right is that they replaced their circumference with 2 pi r. So many times you guys see the formula as the one on the right, a ratio M over 360 equals or times 2 pi r. So let's take a look at example 1 on this one. You have circle O, sorry, there was a typo there. This should say circle O has a radius of 6 centimeters and the arc measures to be 72 degrees. So what we're going to calculate is what the measure of the length of, or find the length of arc PQ We're gonna do that by taking either the central angle or the measure of the arc, putting it over 360 so we can find what proportion of the circumference to apply, and then times it by 2 pi r. So if I'm trying to find arc length, I'm gonna times it by 2 pi r. So r in this case is 6. Okay, so you guys are gonna reduce. I'm gonna share my screen in a bit to show you guys what to do, how to reduce a fraction on Desmos, which is really neat. Like I know a 4th period, they didn't know that that was possible. But essentially, just so if you had to do it by hand, you guys are reducing things like 6 goes into 360, 60 times, 2 goes into 60, 30 times, and then you guys have 72 over 30, which then reduces to 12 pi over 5. I'm going to show you guys how to do that on the calculator so it's nice and easy, but basically every number that's on top over every number that's on the bottom, the pi is either written on top or to the side. So 12 pi over 5 is the length of arc PQ in calculator ready form. Okay, the spin on this is instead of just finding the arc length or how long that pizza crust is, we have something called a sector. A sector is a piece of the pizza or slice of the pizza. So if you guys go ahead and highlight your pizza slice here, and then highlight the word sector. Okay, sector is a pizza slice. And what we're asked to calculate here is instead of the length of the pizza crust, we want the area of that slice of pizza. So in the formula that you guys see above, the area of the sector is the same exact formula as that of the arc length, except for instead of 2 pi r, you guys have the formula for area there, pi r squared. Okay, and that makes sense. You just want the ratio and then times it by the area of the circle. So we're going to do 2 problems here. You have in this picture that some of the points are missing. So can you guys go ahead and call this point J, the center point K, and then this point L? Okay, and they tell us that the measure of arc JL is 120. So we're going to assume this is 120 as well as this angle is 120. Okay, and both mean the same thing. So we're going to do 120 over 360. That's going to give us our ratio. And then since we're finding the area of a sector, we want to use the area formula. So pi r squared. If you look at the picture, it's not drawn to scale, but 120 over 360 reduces to be 1/3. So it's saying, what's a third of the area? So a third times 36 pi. So 3 goes into 36 12 times. You guys got 12 pi is the area of that sector. So reducing the fractions along the way, making sure it's in fraction form, simplified fraction form. Okay, for part B, notice the difference is that for A, they told you that the arc was JL. In the next problem, they tell us that the central angle is 135 degrees. These two are equivalent to each other. So whether they give you the angle or the arc measure, you do the same thing. It's 135 over 360 times pi r squared. Okay, so we simplify. 4 goes into 360 90 times. 40 goes into, or sorry, 45 goes into 135 3 times. 45 goes into 90 2 times. So 3 pi over 2. Okay, and now again, I'll show you guys how to reduce fractions nicely on your calculator in just a minute when I flash over to Desmos. Give you guys a minute to write that down, and we're going to do our last problem here. All right, you guys, so you definitely have one like number, whatever this number is. This example is on your quiz. Okay, so here they give you a new name for it, and the name is basically that shaded region. If you look at that shaded region, it's basically the pizza slice But then what do you guys have to subtract out? So the area of the sector, what shape do you guys have to subtract out? And someone needs the bottom of the previous page, so I'll leave it up there for a moment. Yes, does everyone see how for the segment, which is basically that pizza crust, you have to find the area of the sector and then subtract out the area of the triangle. Does everyone see how the triangle is subtracted out from it? Okay, so go ahead and start. Oh, actually, can you guys type into the chat? What do you guys think the measure of the arc is equal to, of that sector? That was really hard for fourth period to answer. Okay, it doesn't explicitly say it in your in the directions, but you guys can see the central angle is 90 degrees. Now think about that a moment. If you guys looked at this pizza slice, how much of the pizza is this pizza slice? Just give me yeah, good. So fraction wise, this is a fourth of the pizza slice. And so that's where that fourth comes from. When you guys do 90 over 360 degrees, the measure of the arc being 90 over 360, that reduces to a fourth. That makes sense that I'm taking a fourth of the area. Okay, so 90 over 360 times pi r squared, r being 8. So again, 90 over 360 is where we get the 1/4, or visually looking at it, we can see it's a fourth. A fourth of 64 pi is 16 pi. Okay, the triangle is kind of nice because we have the radius. So we have the radius, the triangle is a right triangle. So this is my height and this is my base. So I just do a half times 8 times 8. So when I'm doing multiplying this out, just taking it slowly, half of 8 is 4, 4 times 8 is 32. That's how I would do that simplification, not taking a half of the 8 and then half of 8 again. It's not distributive there. And then lastly, if it's just the area of the segments, we're gonna go ahead and subtract the 2, making sure that the bigger one, which is the sector, comes first and then 32 comes after. Okay, you guys, how much of this was review and how much of it was new? Have you guys seen sectors before or arc length? Has anyone seen sectors or arc length, or is that completely new? New to you guys? Oh, some of you guys did it in pre-algebra. Half was new, half was old. Okay. You most certainly should have seen circles before, and area and circumference. That's covered in every, I think, almost maybe upper elementary school to junior high, but sectors and arc length, I believe, is new. All right, you guys, so the other thing I want to share with you guys is, let me stop share this, a calculator tip. Can you guys open Desmos for me? Or find your calculator. So make sure it's Desmos, make sure it's Desmos scientific calculator, not Desmos graphing. Can you guys in the class see the Desmos on your Zoom screen? Okay. All right, you guys, so a neat hack, if you didn't know it already, let's say you guys were reducing 25 over 100. So everybody enter, well, it doesn't matter what you guys enter in, but like an unreduced fraction, like 25 over 1000. And let's say you wanted to reduce that fraction, but you didn't want to sit there and divide by 5 on top and bottom. So over on the right, it gives you guys the decimal approximation. And then to the right of that, there's this convert to fraction symbol. So if you guys hit that, it reduces the fraction for you. Did you guys know that?